Now, consider an important result. Let x equals xn be a real sequence. Consider a theorem. Let x equals xn being a real sequence. Real sequence means it's a sequence of real numbers. Real sequence. Let x fall in R. This x should be fall in R. Okay. If sequence n be a sequence, let the sequence A, let sequence an be a sequence of positive real numbers. Positive real numbers. Such that limit an equals 0. Limit an equals 0. Then, for some constant epsilon is positive and a m fall in n, then if such that modulus of xn minus x less than or equals c into an. For all n greater than or equals m, where m is a natural number, then limit xn equals x. Then limit xn equals x. So listen, x equals xn being a sequence of real numbers. X is in R. An be a sequence of positive reals, but limit an goes to 0. Limit an equals 0 means an goes to 0 when n goes to infinity. Maybe the sequence an is 1 by 1, 1 by 2, 1 by 3, 1 by 4. That's a positive sequence. And limit an equals 0. Maybe it may be sequence n is 1 by n or 1 by n square, whatever may be. But clearly sequence n be a positive sequence of positive real numbers such that limit an equals 0. When n goes to infinity, an goes to 0 itself. Then for all epsilon is positive and there exists a natural number m with a modulus of xn minus x less than or equals c into an. For all n greater than or equals m, then limit xn equals x. That's our requirement. How to prove this one? Proof is, here limit an equals 0 for all epsilon is positive and limit an equals 0. Limit an equals 0 means there exists by definition of the limit of a sequence, there exists a natural number k such that modulus of an minus 0 strictly less than some epsilon. So here it is epsilon by c, because epsilon is a positive quantity and c is also positive, then modulus of an minus 0 strictly less than epsilon by c. Here for some constant c is also positive. Okay, for all n greater than or equals k. This is by the definition of sequence. Means limit an equals 0 means for all epsilon is positive, there exists a k falling n such that modulus of an minus 0 less than this one. Okay, modulus of an minus 0 less than this one means mod an less than epsilon by c. But what is an? Sequence n means it's a sequence of positive real numbers. Since it is the positive real numbers, modulus of an less than epsilon by c implies an less than epsilon by c. Why? Because sequence n are positive real numbers, positive of a modulus of a positive number, that is the number itself. So it is an strictly less than epsilon by c for all n greater than or equals m. This m falling where? M is in n. M is a natural number. Okay. But it is given modulus of xn minus x less than or equals c into a under the same condition for all n greater than or equals c. Or for all s, it is for all n greater than or equals k, whatever may be. So mod xn minus x less than or equals c into an for all n greater than or equals c. Okay, come to these two arguments. This is 1, this is 2. Means an less than epsilon by c for all n greater than or equals k, where k is a natural number. And model it is given, the hypothesis states that mod xn minus x less than or equals c into an for all n greater than or equals m, m also is a natural number. So for the sake of argument, put some lambda. But lambda equals maximum of this k and m. Lambda equals maximum of this k and m. So this 1 and 2 are held for this lambda. Means these two results hold for n greater than or equals lambda itself. Okay. Now, modulus of xn minus x less than or equals c into what is mod an? So it is strictly less than an by c, sorry, epsilon by c. Why? Because an less than epsilon by c. For all n greater than or equals lambda falling here. C and C are cancelling. This means modulus of xn minus x strictly less than epsilon for all n greater than or equals lambda falling n. So from here we can conclude that xn equals limit xn equals x or xn converges to x itself. Okay, this is what we require here. Okay, right. Now, by using these arguments, so now we can solve some problems. What is the limit of a sequence 1 by n? We know that limit 1 by n equals 0. Okay, this is a well-known result. Limit 1 by n equals 0. How to prove this one? Limit 1 by n. 1 by n always converges to 0. So we know that it is is proved in this way. For all epsilon is positive, epsilon greater than 0. Let epsilon greater than 0. Since epsilon is positive, 1 by epsilon is also positive. Okay, 1 by epsilon is positive. Then by Archimedean property, there exists a natural number k such that 1 by epsilon strictly less than k. Okay, 1 by epsilon strictly less than k. Now, consider consider modulus of 1 by n minus 0 for all n greater than or equals k. There exists a natural number k for n such that modulus of 1 by n minus 0 for all n greater than or equals k. N greater than or equals k means 1 by n less than or equals 1 by k. Okay, so this equals modulus of 1 by n which is less than or equals 1 by k. Clear? Means we say that modulus of 1 by n minus 0 equals modulus of 1 by n, but it is less than or equals k, 1 by k. Why? Because when n greater than or equals k, 1 by n less than or equals 1 by k. But 1 by epsilon strictly less than k means 1 by k strictly less than epsilon. Okay, so it is strictly less than epsilon. That means for all epsilon is positive, this can be rewritten as, that is, for all epsilon positive, there exists k falling n such that modulus of 1 by n minus 0 strictly less than epsilon for all n greater than or equals k. Means all of these arguments are concluded in this way. For all epsilon is positive, there exists k falling n such that modulus of 1 by n minus 0 strictly less than epsilon for all n greater than or equals k. That means 1 by n converges to where? 1 by n converges to 0. That means limit of the sequence, limit 1 by n equals 0 itself. Okay. So, we know that limit 1 by n equals 0. What is limit 1 by n square plus 1? Limit 1 by n square plus 1. What about its limit? So we know that Again, we have let epsilon is positive. Clearly, epsilon positive. Then 1 by epsilon is also positive. Then by Archimedean property, there exists a natural number k such that 1 by epsilon less than k. 1 by epsilon less than k means 1 by k strictly less than epsilon. Okay. What is n? N is a natural number. Since n is a natural number, we have n strictly less than n square plus 1 for all n falling n. This is always true. N should less than n square plus 1 for all n falling n. That means 1 by n square plus 1 should strictly less than 1 by n for all n falling n. Okay, taking reciprocal. So 1 by n greater than 1 by n square plus 1. That means 1 by n square plus 1 strictly less than 1 by n. Now, for all epsilon is positive, now consider modulus of 1 by n square plus 1 minus 0 equals modulus of 1 by n square plus 1. But 1 by n square plus 1 strictly less than 1 by n. But 1 by n when n greater than or equals k, for all n greater than or equals k, that's our assumption, condition. For all n greater than or equals k means it is 1 by n less than 1 by k. So it is 1 by n strictly less than or equals 1 by k, but 1 by k strictly less than epsilon. That means for all epsilon is positive, there exists a k falling n such that modulus of 1 by n square plus 1 minus 0 strictly less than epsilon. That means the secant xn minus x strictly less than epsilon. That means xn converges to x means 1 by n square plus 1 converges to 0. That means limit term 1 by n square plus 1 equals 0. So this is our requirement. Okay, thank you.